Hey guys, this is Sadia Theophilus Tube, and we are going to pick up from where we left off on our last lab configuration. So basically, what we do have here is a CMIN functional network. So we are going to introduce routing protocol EIGRP to have all of our LAN networks talking to each other. So as it stands at the moment, our LAN cannot talk to each other. So for instance, this LAN on the 3.0 network cannot talk to the one network, and our ping is failing, which of course supposed to fail. They are all getting to their gateway on the router, but they can't pass the gateway because there's no API route to the remote network, or there's no routing protocol to route traffic from one network to the other. So all of our gateways are all working, but we can't ping across the network. So basically, that's what we are going to fix in this final segment of this EIGRP lab. So why use EIGRP? EIGRP is one of the robust and best routing protocols you can find out there in the real world. It is used especially in enterprise networks, large networks, networks that are intended to grow over time because it's very easy to scale. And with regards to convergence, EIGRP is very robust with regards to convergence because of the algorithm that is used in the routing protocol. So it is far surpassed that of RIP 1 and 2, IGRP, and OSPF. EIGRP is a dynamic routing protocol. It is sometimes and also referred to as a hybrid protocol because it bears semblance of both distance vector protocol and also a link state routing protocol. So it's what they sometimes refer to as a hybrid protocol, and it's also Cisco proprietary. It is an enhancement of the IGRP protocol, which Cisco had a couple of advanced features, and it is called Enhanced Interior Gateway Routing Protocol. So it's what they use, and it also support VLSM, that's variable length subnet masking. So that's what basically we are going to do to configure EIGRP to have all of our networks talking to each other. If you have a lot of network, you wouldn't want to introduce static route to remote networks. That would be just a lot of work. So you could do just work with the routers, introduce all of your lanes through the routing protocol, and you can have routing going on. So basically, to configure EIGRP, this is the simplest of configuration we're going to do with the protocol. There are lots of parameters that you can follow and institute to have a really robust routing protocol. But since the basics here is a basic understanding of EIGRP, and that's what we are going to do. So there are a couple of parameters basically. So you want to do enable config T and then router EIGRP. EIGRP is almost similar to that of OSPF, but without the declaration of an area, what we do in OSPF. So you want to do router EIGRP, and next to sort of give you an idea, let's do question mark. Now you want to pick an autonomous system number. This number is significant because if you want, for instance, if you want to have this router and this router, this router and this router communicating, they will have to be within the same system number. They will have to bear the same system number in order to form a neighbor relationship. So we're going to use one here. We could pick from 1 through 65535, but we're just going to pick one. We do enter, and now you want to specify the networks. Okay, since this is R1, you want to work with all the networks that are directly attached to that router interface. Alright, you want to work with all the networks. So basically we have this LAN right here, which is 192.168.1.1. This should be 1.0. 1.1 is the gateway. Okay, and then the links that are coming from other routers to this router, you want to also include that in the network, in the EIGRP statement. I'm sorry. So we have 10.10.10.12, which is linking this router and this router. And we also have 10.10.10.0, which is linking this router and this router. You wouldn't want to include this link, because they are not directly touching this router. These links will be configured on the directly connected routers that we have here. So you just want to work with this link, this link, this link. Alright, so it's the networks that we want to mess around with. So you want to do network. So 192.168.1.0. so that is for this LAN right here. Next, you want to do Waka mask. Okay, EIGRP support Waka masking as OSPF, but without the area. So what is the Waka mask? So let's do question mark and we'll have an idea of what the Waka mask is. So EIGRP Waka mask, the bits. Alright, so the Waka mask is an inverse of the subnet mask. So what am I saying? Our subnet mask, let me put this up right here. Our subnet mask is usually 255.255.255.0. that will be for /24. Now to find the inverse part of this mask, you want to do 255.255.255.255. Now to find the inverse portion, you want to do a little subtraction. Alright, so what we're going to do, when we subtract from here 255 from 255, we're going to get 0. Okay, we subtract 255 from 255, we get 0. 255 from 255, we get 0. And you get 0 and you subtract 255, you get 255. So basically this is our Waka mask, and this calculation applies to all the slashes we can find within the different subnets. So if we have 252, we're going to subtract 255 from 252. What we get will be 000.3, which will be for /30. The same goes for /29, 28, 27, 26, 25, 24, and all the way down the line to /8. Alright, so for /24, our Waka mask is going to be 255. Going to be 0.0.0.255. Okay, so that's what we're going to put right here. So do 0.0.0.0.255. Now we wouldn't specify an area because that is for OSPF. So that will be it. To find out, see what we have left here. See arrow, that means that's all the configuration that is needed in this space. Next, we want to do network. We want to add this network right here, 10, 10, 10, 12. Alright, since it is a /30 network, our Waka mask is going to be 0.0.0.3. so it's 252 minus 255, we get 3. We do enter, we do network 10, 10, 10. Next, we want to do this network right here, .0. That is also a /30 network, so we want to do 0.0.0.3. We do enter. Now there are a lot of parameters that we can set, so let's do question mark So these are all the parameters that we can configure on within the EIGRP statement. So we want to do no order, okay, because this support by default auto summary is enabled within EIGRP. Now with us disabling auto summary, we wouldn't have our networks auto summarize to their default class 4 addresses. All right, that is important. If you have VLSM IP addressing, you wouldn't want a couple of routes auto summarize, because if that happens, there wouldn't be adjacency formed with other networks, and we wouldn't have routing to those networks. So we want to disable auto summary. So we want to do no auto summary. You do enter. Another thing you could do is indicate a distance from defined an administrative distance from a particular router interface to another, but we are not going to do that. You also want to make an interface a passive interface. So what we're going to do is we do passive interface, and we want to suppress routing updates coming out to the LAN. So we want to do F0/0. So all the routing updates are going to be pushed around. It's going to be right within this space, and they are not going to be pushed onto the LAN network, because that would just be completely unnecessary. You want to do enter, and we could also redistribute a default route if we have any. So like you see here, redistribute information from another routing protocol. If we have a couple of other routing protocols running on the network, we could use this command to have those routing protocols or those updates redistributed through our EIGRP network. But since there isn't any, that will be it for our EIGRP configuration on arrow 1. We'll do end, and we should be fine. Alright, so we want to do the same for arrow 2, and then we're going to form our neighbor adjacency. So we're going to do that very quickly, since we now have an idea of how it's supposed to be done. Router EIGRP1, you have to maintain the same autonomous system number. You do enter, you do network 192.168. our network here is .2, so that's what we're going to do. .0, so we do 0.0.0.0.255. okay, you do enter. Network 10.10.10.0. okay, 0.0.0.0.3. do enter. Network 10.10.4. okay, 0.0.0.0.3. okay. Next we want to do passive, because we don't want routing updates coming off this interface. So we do FA0/0. we do enter. As you can see, there's already a neighbor adjacency, so this router is now seeing this router. Okay, basically that's the message we are getting right here. So that is excellent, that is good. We could also give the router an ID. So we want to do, but we don't want to do that right now, so we're just going to end this configuration right here. We should be fine. Okay, next let's do arrow 3. For arrow 3, the steps are the same. It's pretty straightforward. Like I told you, this is one of the simplest configurations, so we are not going to mess around with a lot of parameters within EIGRP. It's just a basic concept, EIGRP. So let's do router EIGRP1, maintain our same system number. You do enter, you do network. Now you want to include all the networks attached to router 3 in our EIGRP statement. 192.168 3.0.0.0.0.255. Enter. Network 10 10 10 8 0.0.0.0.3. Enter. Network 10 10 10 4 0.0.0.0.3. Enter. Now we have an adjacent set again. We do passive interface f80/0 to enter. We do end. Okay, that is it. And next we're going to do the same for router 4, and that will be the conclusion of our EIGRP configuration. So enter config router EIGRP network 192.168 at 4.0.0.0.0.255. You do enter. Network 10 10 10 the 12 0.0.0.3. okay, now we also have an adjacent set network 10 10 10 .8 0.0.0.0.3. You do enter. Also an adjacency. Next one, do passive interface, because we don't want routing updates going through that interface. You do enter, and we should be fine. Now basically with this configuration we should have all of our networks talking to each other basically. So let's try that out and see what we got going here. So we want to ping from this LAN to this LAN. As you can see, it's successful. That is good. So this is all good. Okay, let's try this one. So basically this should all be able to ping because we've introduced a routing protocol. Without a routing protocol we wouldn't have all these networks talking to each other, even though they have routers attached to them. So basically that's why routing protocols are important on the network. Now to restrict access to different LAN networks, you could introduce an access list to restrict access to different networks on your LAN. So that's another configuration. But to finally test this out, let's add another client PC to one of these LANs and see what happens. So let's put a PC right here, and then we're going to pull an IP address from that, and then we're going to do ping over and see whether we will have connectivity. So let's do that very quickly. Let's move this up here. So as you can see, we have our DHCP server right here. So we don't have to configure basically anything. We just want to pull our IP address from our DHCP server, and that should be totally okay as well. So do that, and then want to take the next available port, do a fast forward. You can up here, desktop IP configuration DHCP. We should have an IP address assigned to this client on our network. There you go. So our next available IP address, as you can see, is 192.168.3.11, 255.0, 3.1, 253 is our DNS. So that is functioning very nicely. Now let's ping from this new client over and see what happens. That is successful. Let's do this from this one. We want to do ping, but first we want to see what's our IP address on this client, because okay, it's .10. So we want to ping .10 from this client and see what happened. 192.168.1.10. So as you can see, we are getting replies. So this is great. All right, Let me stretch this out for you. So our round trips will make 192 packets send 4, receive 4, loss 0, 0% loss. So this is to tell you that we are reaching our intended target. So let's do a trace route and see how many hubs we pass through to reach 10.10 192.168.1.10. So let's see. Oh, okay. So let's do this. Trace route, trace set for Microsoft. So trace route will be arrow. I'm forgetting this command, my goodness. So trace set, okay, let's do trace set. This should be, there you go. So as you can see, these are all the hubs that we get through to reach 10.10. So to fully explain this, where did it go? To fully explain this, let's put this aside. So 192.163.1, this is our gateway right here. So this is the that's the 3 interface. Next we move to 10.10.5. So 10.10.5 is okay. So next we use this router to go to this LAN. So 10.10.5 is right here. Next we move up to .13. okay, next we hit 192.168.1.10. so this is our route right here. We pass here and then up here. So basically that will conclude our EIGRP configuration. As like I told you, it's fairly straightforward. You just want to do a decent IP addressing and everything should work just fine. So let's ping from here and here and see. Successful. That is great news. So guys, let's hope you are getting along, and kindly please subscribe to my channel. Leave me all your comments, your dislikes, and of course your likes. I'm Sadia, and thanks for watching.